students will also join in this class. Is there anyone from section 1? Have you got the information?
Yes, sir.
Okay, so thank you. Okay, let's wait 2 or 3 minutes, then afterwards I will start. Ali Abir Shubro is here.
Yes, sir.
Okay, Shubro, after the class, please
Okay, sir.
please attend this schedule or the meeting. Don't leave this meeting. Okay.
Okay, sir.
I have to something I need to discuss with you. Okay, let's start today's class. Recording. Okay, so today I will finish this lecture. Thank you, section 1, that in the morning, due to some important meeting, I couldn't take the class. So that is why I merged to section 2 altogether. And the topic, we are almost at the end of this topic, just a review of earlier class, that we are talking about 8259 interrupt controller, and already you got the, the idea that to handle the interrupt related things with the microprocessor, one specific type of integrated circuit assists the microprocessor to handle all sorts of interrupt related things. The most important interrupt related issue is that priority resolving. You know that whenever multiple interrupt request comes to the system, at that time, among the interrupt request, the one that has the higher priority, that should be served, or that should be executed. That interrupt request should be executed. And one important role is played by this type of interrupt controller, that is the priority resolving technique. And we have discussed about that some sort of arbitration using priority arbitrator. And this priority arbitrator, actually, this is the integrated circuit. This is working as an interface as well. And this makes the interfacing between the peripheral and the microprocessor. And this works in between the peripheral and microprocessor. And this solves all sorts of priority resolving issue on behalf of the microprocessor. And that is why we say that this priority arbitrary circuit actually removes the burden from the microprocessor regarding the interrupt issue. And also we have talked about without having any priority arbitration, without having any additional circuit, we have seen one structure, that is a daisy chain architecture, and where the downstream IC plays the role of scheduling between the peripherals, and usually the closest peripheral has the higher priority, and the distant peripheral has the lower priority. But the main problem of this, that if there is any cut or any disconnectivity issue, in that case whole system will be down. And we have also talked about the multi-level bus architecture. This architecture usually follows by the large scale embedded system, and where we can see that we have to use some bridging circuit, and this bridging circuit plays the role of the priority arbitration. So everywhere we can see that in this multi-level bus architecture, we have seen that the most important integrated circuits are connected through one bus, that is the processor local bus, and the peripherals are connected through the peripheral bus, and in between them there is a bridging circuit, and this bridging circuit makes the interrupt request on behalf of these peripherals, and this is working as the you can say this is the priority arbitrator or priority resolver circuit. So by learning these three architecture, we have come to an end that we are talking about one particular type of programmable interrupt controller, that is the 8259, and it can handle maximum 8 interrupt requests through these 8 pins. Those pins are indexed by interrupt request 0 up to interrupt request 7, and this 8259 is directly connected with the microprocessor, having an 8-bit data bus. But you can use more than 8-bit using one multi-level use of 8259 interrupt controller, and how that I have shown you in my earlier class, that using a concept of master slave concept, using the 8259 in the master level, 1 in the master level, and 8259 in the slave level. Ultimately 8 into 8 means 64 logical peripheral connection or logical parallel interrupt request can be reached to the microprocessor. So these are the things we have discussed in our earlier class. Today I will talk about a bit details about the block diagram and pin diagram. So in this block diagram, you can see that in this block diagram architecture of 8259, in the left side we have the block diagram, and at the right side we have the pin diagram. You can see that in the pin diagram we have the 8-bit data bus D0 up to D7, and also we have the chip select, and you are already being familiar with chip select because it needs to be grounded, or any logic 0 signal has to be reached to the 8259 for selecting this particular 8259 IC. Read and write operation always comes from the microprocessor, and interrupt request is requested towards the microprocessor, and interrupt acknowledgement is coming from the microprocessor. We have the VCC and ground pin, and D0 and D7 is also connected with the microprocessor. We have some special pins, cascading pin 0, 1, and cascading pin 2. I will show you the operation of cascading pin today. Also, we have the SP or enable pin, and these actually use the master slave concept. The concept we have just seen in our previous slide. I will discuss about that. But you can see that interrupt request 0 up to interrupt request 7. These pins are used to receive the interrupt request from the peripherals. This is the pin diagram issue, and we have another address pin, that is the A0, and A0 has some specific task. Now we can map these pins in this block diagram. So in this block diagram, you see on the left side, always I say that on the left side you should in this course, in peripherals course, always I say that, just a minute. And at the left side, our microprocessor is there, and this is our interface, that is the 8259, and at the right side, our peripherals are there. So the interfacing here for the interrupt purpose are done by are doing by the 8259. Here we can see on the left side, the data bus is connected with the CPU. The read signal and write signal is coming from the CPU. Address for particular logics are coming from the CPU. For selecting the chip, it should be grounded. We have some cascading bit. I'll show you the cascading cascade buffer comparator. And for enabling the master slave concept, we have to use this SPR enable pin. That means whenever the master slave concept is utilized, at that time only we use the cascade pins. So this is the left side part. On the right side part, you can see that peripherals are connected through these 8 pins towards the 8259 interrupt controller. And inside the pin interface, we have the priority resolver. You see, we have the priority resolver that solely works with some applied logic, that is the programmed logic, whether it is sequentially it will resolve the priority, whether the highest ID has the highest priority or the lowest ID has the highest priority. Those are programmed through priority resolver using some control logic. And priority resolver works with the control logic. That means we have to put some command to the 8259, that how it will perform the priority resolving in between the interrupt request. Also, we have 3 types of registers. One is interrupt request register that stores all sorts of interrupt requests. Now, parallelly, 8 interrupt requests can reach to the 8259, and those requests will be stored into this interrupt request register. And after that, among the interrupt request registers, the one that has the highest priority, that priority will be resolved by the priority resolver, and that interrupt will be processed, and that will be marked as in service or in processing status, and that in service processing status will be shown by this interrupt service register. And also, whenever the interrupt request is placed, that interrupt request will be placed by the INT pin. You can see the pin also in the pin diagram in the pin number 17. And that interrupt request will reach to the microprocessor, and microprocessor will eventually send one interrupt acknowledgement through this INTA. And you can see that interrupt acknowledgement works with logic low signal, and interrupt request goes with logic high signal. And lastly, we have the interrupt mask register. Suppose one high priority interrupt is now in service, that is recorded by the in service register. But at that time, that particular interrupt type will be masked, and that will be stored here. Now, if any low priority interrupt request comes at that time, as we are having one masking interrupt request, so that is why that low priority interrupt will not be served or will not be executed. But if we are having a low priority interrupt and that is being masked, at that time, if any high priority interrupt occurs, at that time we will unmask that low priority interrupt and eventually the high priority interrupt will be masked. So the masking means the interrupt that has the highest priority, that is already been executed or executing by the system, that is need to be masked, and that is need to be identified by the interrupt mask register. So this is the particular use of interrupt mask register. So the difference between interrupt service register and mask register is that interrupt service register just will store the status of the interrupt type, but whether that is a highest priority interrupt or lowest priority interrupt, that is not being described by the interrupt service register. Rather, who stores the highest priority interrupt information? The highest priority interrupt information is stored by the interrupt mask register. So at a glance, I have discussed the block diagram, but now I will move to one particular reading article. From there, I will discuss some of the aspects of this block diagram. Let's move to that. So this is your, I think it's visible to all of you. This is your reading article. It's a 8-page reading article. I have found that is very helpful to understand the programmable interrupt controller, specifically the Intel 8259. And the thing I have discussed till now, you can see the point wise, I'll just point it. It has 8 interrupt inputs. So fine. I will discuss some of the major points. We can have 8 levels of interrupt priorities. Thing I want to highlight. Let's go there. I have discussed about chip select, write signal, read signal, data bus that is connected to the microprocessor. Now, why I have come to this slide? Actually, I have to discuss about the CAS 0, that is the cascade lines 0 to 2. Now, cascade lines, why do we need cascade lines? And at that time, the SP or enable buffer or slave program, this should be enabled for the 8259. Now, the figure we have seen just a few minutes back, that let's say whenever I start with a new document, it takes some time to draw. Let's say here we have the 8259, and this is the IRQ0, and this is the IRQ7. Now, with these, we may have total 8 8259 interrupt controller connected. Okay. Now, but only, and these are having their own IRQ0 up to IRQ7, for it as well IRQ0 up to IRQ7. Now, if we are using this slave program method, so of course at that time a logic 0 signal should be sent towards the master 8259. That means the point we have seen SP/EN. So through this pin, a logic 0 signal, or it should be grounded. So at that time, the system will understand, okay, the 8259, this 8259 is working as a master slave or master interrupt controller, and it is connected with maximum 8 slave 8259 interrupt controller. Now, how to select those 8? Because it is now working as a master slave method, so we need to use some cascade method. So we are having 3 cascade lines. So CAS2, CAS1 and CAS0. So we have the 000, 001, 010, 011, 100, sorry, 101, 110 and 111. So we are having the 8 index. So this index belongs to the first 8259, the second 8259 and the 8th 8259. So from which 8259 the master 8259 is collecting the interrupt request, so that is actually defined by the cascade lines. Is it clear to all of you?
Yes.
This issue. Just few minutes back, I have shown you that the 8259 can work as a master. This 8259 is working as a master line or master interrupt controller, and it is connected through these 8 pins. It has 8 pins. Actually, though I have drawn only 2 pins, so let's say dot dot dot. And through these 8 pins, maximum 8259 we can connect. That is the number of 8259 we can connect. That is the 8. So this is the first one, and this is the 8th one.
Sir, there appears to be a problem, sir. I think using the link for this meeting, I think a few people are still unable to join. They've been complaining about this for a bit.
From section 1, or section B, 2?
Sir, both sections. Both sections are having a few problems. Like it took me 2 tries to join this meeting, but I think even using the same link, a few of them are being unable to join.
Oh, really?
Yes, sir. I tried giving them the password and the meeting ID. They still were unable to join. Then I tried giving them the link. They still, some of them could join, but some, I think around.
Yes, I can see that total 49 students have joined out of 75, because in total you are 75 in this semester.
Yes, sir. And some of them, I think they are. Is there a different room?
Okay. Is there any error code it is showing by the Zoom?
Sir, no. They're basically being placed in a completely separate meeting or a separate room. There are like 7 of them there, and.
Okay, I think Akib, are you there from section 1?
Sir.
Akib, can you provide the link of section 2 to them?
Yes, sir. I have already provided, sir.
Okay, thank you. Okay, so what I can do now, I can't do anything, so I'm recording it, so I'll provide the recording file. So this is the ultimate solution. Okay, and please try to give them the link. If they found any error code, so there is a system problem or network problem at their end. Sometimes it happens from my side as well. But if there is no, I think there is some problem with link mismatch or link ambiguity. So you can try to give them the correct link. So please.
Okay, sir. I'll ask them to try again using the link as well as the passcode and the ID.
Okay. Thank you.
Thank you, sir.
So let me proceed. Okay. So the thing I was talking about, that this is the master slave concept. So you can see that 8259, this 8259 is working as a master node, and it can connect maximum 8 slave nodes. And how it can, if it works with the master slave mode, at that time only this cascade buffer will work. And you see the cascade buffer, we have 3 cascade pins, cascade 0, 1 and 2. So that means we have, with the use of these 3 pins, we may have maximum 8 alternatives, and through that 8 alternatives, the master consider this IC as a master node, and with that a maximum of 8 slave nodes can be selected. Now that is the thing I was showing in my this figure.
Uh, Sir, I'm sorry I'm interrupting again. Sir, are you hosting this meeting from the BDN account?
Yes, from my BDN account.
Sir, is
Hello, Fad.
Sir, what?
My one is professional account provided by BDN and maximum 300 participants we
Okay,
can
sir.
here. My one is a professional account. I'm using for last 8 months. Mm, okay, so it's a new problem we are getting. Maybe they are getting some error code. So most probably, so far I guess.
Sir, it's not like an error code. Like they're going to another meeting. Like not directly this one.
So who are there in that meeting?
Sir, it's not an error code. It's I don't know actually, but actually when I connect with my phone, I'm inside that meeting, and when I connect with my laptop, I'm already here with you guys.
Okay. So in an unexpected error. So we will look at that. So let's please proceed with the class. Who are here, please continue with that class. So as I can see that maximum 50 participants are there. So I will query about that. Okay, after the class, inshallah. So I'll talk with the technical person about this issue. Okay. So I was discussing that we are having that cascade lines. So these cascade lines will help the master node to select the slaves with the 3 alternatives, with the 8 alternatives through the pins CS0 up to CS2. And of course, at that time, the slave program should be enabled with a ground signal or logic 0 signal. And we have the interrupt signal, interrupt acknowledgement signal, the interrupt request signal. These are the things I have discussed from the block diagram. Okay, now one specific address line that is the A0 will be used, and why do we need that? I will show you from the slide. Okay, don't be worried. Please tell your friends that they don't need to be worried about the attendance today, and I will provide the class lecture recording so that they can have the makeup also. So I got the message that there is some technical problems.
Okay.
So please inform them. So don't be panicked. Okay, so I have discussed more details about this block diagram than the operations. So again, what specifically we are having the 3 types of registers. Interrupt request register. Initially, it stores all sorts of interrupt requests. Those are coming from different peripherals. We have the interrupt service register, the interrupt currently being served by the system. That record or that status is stored in the interrupt service register. The interrupt mask register, this holds the among these, if there are 8 interrupt requests are coming, and among those the one that is having the highest priority, that is being masked into the interrupt register. And if at that time any new interrupt request come with more higher priority, in that case the earlier one will be unmasked and the new one will be masked here. So the difference with the interrupt service register and interrupt mask register, it only the interrupt mask register holds the highest among the all requested interrupt types, and the interrupt service register is holding only the currently executing interrupt information. And the priority resolver works with the control logic. That means this is the program logic we can apply. That is why we say that programmable 8259. And the interrupt requests are sent through INT pin and interrupt acknowledgement are coming through INT pin. So, though 8259 can work with maximum 64 parallel interrupt requests, but at a time it can serve up to 8 hardware devices. So it may come, the 8 hardware devices, it may come from the master slave concept, or it may come from 8 different hardwares. And you are already being come to know that interrupts are received on interrupt request 0 pin through interrupt request 7 pin. And 8259 can be programmed to assign priorities in several ways. It may be programmed with fixed priority scheme, or it may be programmed with types of interrupts. Just to give you one example, that interrupt request 0 has the highest priority and interrupt request 7 may have the lowest priority. So this is how a fixed priority can be assigned. Or it may be programmed with the types of interrupt that we have seen in our interrupt lecture in microprocessor course. And already I have discussed about the interrupt request register, interrupt service register, interrupt command register. And interrupt command register is the control logic, and it is used to program the 8259 and interrupt mask register. Now, how to program the 8259? 8259 has 2 modes of operation. One is initialization mode, another is operational mode. And initialization mode, you know that initially some command needs to be placed, and just after that, 8259 will be fully operational. And to make it fully operational, we have to write a 9-bit command to the programmable interrupt controller. So here comes the use of 9-bit. So you know that from the microprocessor part, from the microprocessor end, we have 8-bit pins D0 up to D7. But so now how the microprocessor can place 9-bit? So here comes the use of A0. So this is the address pin. So the LSB 8 bits will come through D0 to D7. These 8 bits will come through the data bus, and the 9th or the MSB bit will come through the A0 pin. So that 9 bit will be stored into this control logic with some control information, bitwise control information, similar to the 8255 or 8155 we have seen. So that is the thing. A series of 9-bit values is sent to the PIC, programmable interrupt controller, and once it's begun, it must be completed. And in the 9 bits will be sent to the data bus, the 8 bits, and the 9 bit will sent to the by the address bus, that is the A0. Okay, this is the last slide of today's lecture, and that is that after the initialization, or after the command is placed into the control logic, the 8259 chip will be ready to accept the interrupt request from the peripherals, and it can work with 4 different modes, 4 different command modes in the operational mode. One is fully nested mode. If you can recall that what is fully nested mode, I'm showing you. So suppose this is our regular program. Suppose this is our regular program. I'm not writing any code. and at this point any interrupt occurs. So let's say interrupt N1 occurs, and that interrupt N1 will be executed as it is having the highest one. But at this time interrupt N2 occurs, and that is having higher priority over interrupt N1. So at that time the N2 will be executed first, and after that, after completion of this, from this position the rest of the part will be executed, and after that the control will come to the regular program. So we say this is the fully nested mode, and usually the system works with most commonly each of the computer system works with this fully nested mode. And the second one is the rotating priority mode. This is the fair mode, but the 8259 can be programmed with a rotating priority mode. That means the highest one, then the second highest one, the third highest one. So this is how up to the lowest one, and it's a round robin fashion, you can say. Some special mask mode. Special mask mode means you know that we have NMI. So this is a special non-maskable interrupt, but it has a higher priority. Highest priority. Though it's a non-maskable interrupt, but we are having one specific pin, that is the NMI pin in 8086. So some interrupt like divide by 0. Though it's a software interrupt, but it's an NMI interrupt, non-maskable interrupt. We can't avoid that. We can't make any delay. So it cannot be waited. Otherwise the system will not work. So some special mask mode can be enabled in 8259. And finally, so we have learned about fully nested mode. We have learned about the rotating mode, the special mask mode, and finally the polled mode. You know that polling is not interrupt operation. Rather, the microprocessor via the 8259 interrupt controller will knock each and every peripheral that whether they have any request for interrupt request or not. So this is the poll mode. Ultimately, this is whenever any standard defines for any IC, so it should cover every possibilities as it's a programmable one. So that is why we say 8259 is a programmable interrupt controller. It can be programmed with fully nested mode. It can be programmed with round robin fashion. It can be programmed with special mask mode and poll mode. So this is, I think, this is the last slide, and this is all about our 8259. And you know that whenever any interrupt executes in the system, it should go through these stages. Stage 1, these 3 values will be pushed into the stack, and a new flag value, new interrupt ID or action needs to be executed. And after that, it is upon entering into the action or before exiting the action, the system will face a new flag, and the vector is high in terms of memory and vector low in terms of memory with a CS value, you can say, or IP value for that particular interrupt service routine. And finally, again, this will be popped, and from the flag or from the stack, the new flag, the old flag, the old code segment register value and old instruction pointer value will be retrieved. So this is all about my interrupt related topic, and we have 2 more topics in this course. One is DMA controller, and another is the external interfacing, likewise the USB, HDMI, fiber wire, So this sort of interfacing I will talk about in my last lecture. So I think our semester is up to 8th of January. So in the next Friday, I will start with a new topic, inshallah. That is the DMA controller. And afterwards, the rest of the classes will be on external interfacing. Any question regarding this lecture or any other topic? So how IUT is thinking of, because University Grants Commission has approved in-person exam, final exam, and how you guys are thinking of, or though you are not final year, but there is a declaration for the final year students that the Public Service Commission of Bangladesh, they have declared for 43rd BCS, and those who are interested for the government job in Bangladesh, they have to sit in the final exam within 31st of January. So this is so we are handling this sort of crisis issue or crucial issue in our university, and we are working with the online exam. So is there any possibility of in IUT for in-person exam for the final? Have you heard about that?
So for this semester, I think the final will be online, but after the final, there is 1 month of physical labs, I think, for makeup labs that were made
Okay.
for other departments.
But yesterday or day before yesterday, we got one official letter from IUT that this time the IUT admission test will be held on 13th of February, and the IUT authority is planning to have the exam centers in Rajshahi at Ruet, in Gazipur at IUT and Duet, in Chittagong at Chuet, and in Khulna at Kuwait. So they have sent us an offer letter. If we agree, then the exam center will be at Duet. So there's the thing I have heard. So if they are allowing the in-person admission test, I think from the next semester, you may be allowed to enter into the campus, hopefully. Okay. Good luck, inshallah. So with this, I am finishing this class, and hope to see you on next Friday with the new theory class, and section 2-1 group will have the lab on Thursday, inshallah. Okay, and that will be the last lab, most probably, inshallah. Okay, so thank you. Only Shubro, you please stay back, and others you may leave. I have to discuss something with Shubro. Thank you.